driving my research. But the one good thing about these decision tree models as well, they're quite good at kind of accounting for the wisdom of crowds, right? So the idea being that hopefully on balance, my prediction is better, even if there's a few dodgy logs in there. If they're all dodgy, because it's quite possible that everyone is over predicting like feldspar because it sticks out, right? So if everyone's doing that, my model is also going to be biased. But yeah, it would be good to check like ground truth fit as well.
Okay. Thank you, Tom.
Thank you very much.
Okay, so continuing with the northern limb session, but going away from Anglo to their near neighbours, Ivanhoe. And Tim Dunnett from Ivanplats is going to give us an overview of what's going on down there.
Afternoon, everyone. Thanks for hear me talk, but I'm an exploration geologist, not an academic. So we're going away from some of the more academic side of things. But I'll give an overview of what's been happening. I was part of the exploration team from 2010 to 2016, and then segued out of the bushveld to the copper belt. But I've come back to carry on doing some exploration that I'll talk about at the end. The obligatory. So one of the things to say is that there have been over 50 Ivanhoe geologists working on this project over the time, plus many of the academics sitting in this room from various different universities, without which our knowledge would be greatly diminished. So I think Ivanplats definitely has the view that there's a lot to be gained from this collaboration. We're in the northern limb. So we're on Turf Spraits and Makalakaskorp, a little bit further south. Just to take you through a little bit of the history. So we picked up the property in 98, 2023, and we're going to start mining next year. So that's sort of the timescale to get a project into production. So when we picked up the ground, we looked at Mogalakwena, big open pit. Let's go and find one on our ground. Didn't quite work out, but towards the end of that exploration, drilled some holes down dip and sort of started seeing that there was a little bit more interesting mineralization happening. But then 2008 happened. And so we got an injection of funding in 2010, 2011. And drilled some of the yellow holes. These are drilling by year, and sort of started to see that the dip wasn't quite as steep as it was thought. And so then we pulled the trigger and started drilling with 30 drill rigs to put out a resource, 10,000 meters of core per week. So Marion had said in her talk, the best geologists are the ones that see the most thin sections. I'll just sort of change that up to say, see the most rocks. And we were, as a team, very fortunate to see so much material so quickly, seeing a mineralized intersection every few days. That really was a step change in our understanding of what was happening on our property. And then we sort of carried on drilling and got away from some of the assimilation and a lot of the later work that was done trying to correlate the northern limb with the rest of the bushveld, taken from some of these cleaner holes a little bit further away. Continued drilling and working, and at the same time then produced a resource and got our mining license in 2014. And then it was sort of handed over to the engineers and started blasting to start sinking the shaft. This is where we are today. So there's shaft 1. it's down at 1,150 meters. So being developed, all the developments are going out for the start of production, full production at the end of next year. And this is shaft 2, sort of changing the skyline of Mokopane. It's going to be over 100 meters tall, and that'll be the main production shaft. Right, this is our resource, the classic Northern Limb 1:1 platinum palladium ratio at a 2 gram cutoff with the associated nickel and copper. So this is what it looks like in terms of your grade profiles. A lot of you know this, sort of the perched upper mineralized zone, that's felspathic peroxenite full of sulfides. They come down across a plus or minus a chrome stringer and become pegmatoidal. Sort of that's the key change in terms of mineralization. And you know, you've gone from 15 grams per ton up to less than 1. So it's a very important contact. So the peroxenite that sits above the Hartsbergite unit full of olivine, and then below that into variable assimilated rocks. Fundamental, the top contact here is the chrome stringer. Sometimes it's not there, but critically important to notice the textural change between the rocks. So how did we get there to sort of pull out all this information? Just some of the history. We took Jeff White's ABC peroxenites from the up dip and applied it. And as we went down dip, we sort of started to recognize some patterns. We didn't have machine learning then. We had to learn by ourselves. But we started to pull out the basis for what became initially the turf sprayed cyclic unit. And then this is from Darney's paper in 2019 of sort of pulling out the finer details of the Merensky cyclic unit. Very important, you know, it's not always clean. We often have this assimilation zone, paraperoxenites and Hornfels assimilation zones. So I'm just going to also take you through sort of our progressed learning. This is section 11 that we're going to go through the heart of the deposit. This is a 2010 section, so sort of just a few drill holes through our B peroxenite horizon and then down into the floor, and sort of started thinking, okay, well, we're getting away from the Transvaal. This was in our PFS. So it's public data out there, what we were thinking as we were going, getting the contamination, and then deeper down, it's a bit cleaner. Sort of just the slow progression, building in the structural models, adding a bit of detail into the hanging walls and footwalls. And this is sort of where we are today. This is from Darney's paper 2019. So sort of understanding the hanging wall and the footwall zones a lot better, where the Hartsbergites are being developed and the orthoperoxenites in blue. The main zone, I'll agree with Judith, is very interesting. What we've got here is the tennis ball marker. This is what it looks like in the core. Remarkably small little peroxenites that sit in a gabbronorite, believably persistent in all the holes except 2. I think I didn't find it. It was crucial in our structural model interpretation, having something higher up. But very interestingly, it's sort of tracking the top of the mineralized horizon or the critical zone until it becomes flat, and then you see it sort of falling away, and then up dip again, it starts to steepen up again. So what is happening in the magma chamber here to have this thickening, sort of filling in this trough? So the next step change is going to be underground. So there's been one chance to see the top of the contacts. That was when shaft 1 went through the reef. So happened to do it at midnight or 2 a.m. So there I am with a couple of the other Joes. So this is the reef. You can see the top contact very clearly. It's dark underground, as Bob said yesterday. This is for race, so very interesting textures. Shaft is in the part of the reef that's very disrupted and sort of the most complicated. That's why it's there, because it's sort of the lowest grade. It'll be mined right at the end. But zoomed in from that, this is a chromatite that's going vertically. I can show you some other pictures. So that's the Platt Reef. Now I'm an exploration geologist, as I said, so we want to find more. What next? So there's been this Mokopane feeder that's been known for a long time, but no one's really done anything about it in terms of an exploration target. We are crazy enough, I guess, to go and investigate it. So all the little black dots are the sample location. So this is very well constrained. The geophysics session on Wednesday was a great introduction to this. So I talked you through the model, but essentially there's a big gravity, really thick portion of the Rustenburg layered suite. In 2012, we flew a gravity survey over turf spray, just a small portion. And what we were able to do is image the top of the critical zone, so that the contact between the main zone and the critical zone beautifully. We predicted a sort of flat extension, went and drill tested it. And there's Donnie, very excited to have got the intersection within 5 meters of what the model predicted. Very important, it's not uniformly dipping, right? So you can see different orientations. So this is sort of just a zoomed in portion of the Mokopane anomaly. And so these are our original 2 mining licenses. We've picked up these 3 exploration licenses. And so this is sort of just a little bit more detail added into the existing data. What are we going to do? So we've flown a high-res magnetic survey. There's the plane going past our shaft. So it's flying at 35 meters. So you get really nice data. And we're going to fly a Falcon survey at the end of the month. It's going to start. And then based on that, we're going to decide where to put our drill hole this year and go and Mokopane feeder. So we know there's a lot of lower zone. We don't know much else. So let's see what we can find.
So terrific. Thanks, Tim. Okay. Questions for Tim? So
just a comment, really. Have you got the downhole geophysics? The mag and susceptibility and density?
Yeah, so we have done a very small amount of it on a few of the holes up in the mining area. But yeah, so we'll definitely run all of that on the new hole. But yeah, so I mean, we built that in to really constrain this inversion. Yeah.
Exciting time. Great. How extensive is that flat reef? Is it very localized on your concession, or could there be more of these kind of shelves along?
So I'm very interested to see the gravity data that we're going to get. This is over just a very localized area, but so the survey that we're going to fly is going to be much more extensive than this. So yeah, I mean, from the previous inversion, we've got the parameters to sort of run that on that contact. So if the small area shows us anything, I think it's there's great potential for finding more sort of flattening features.
Okay, thank you.
How deep are you prepared to go with that feeder hole?
So the books have it at 2.5 kilometers. So again, for the academics,